Hello and good morning LinkedIn and YouTube, and welcome to the first video where I'll be reviewing as comprehensively as I can electric propulsion technology. Now in this first video I'll be discussing a company named Eviation and their product Alice, but also more in depth the electric motor technology from another company named magniX. Now my interest in energy storage systems such as solid state lithium ion, hydrogen based energy storage, valve regulated lead acid, vented lead acid, nickel cadmium systems goes back 20 years. So this is very personal to me and I'm really excited to be sharing it with you today. But as we look at the impacts that electrification, electric propulsion on transportation is going to have within the next 3 to 5 years, it's going to be profound indeed. It's going to be enormous. And we often think about Tesla only right now and just the way that autonomous navigation in cars is going to be impacting the world. But these types of technologies are just around the corner. Companies such as Amazon and Uber are investing billions of dollars in autonomous navigation and energy storage systems in regards to transportation, because the way that we are kind of guided in the way that we're moving around the United States and the world right now is we use these massive 747, 777s, which are designed to go 1,000 miles or more. And technologies like this will allow us to start utilizing regional airports, within 200 to 300 miles away, becoming much more efficient and utilizing technology that has a lower carbon footprint on the world. That's obviously more carbon neutral, but in the way that it's generating a lot more opportunities for organizations across the planet. So it's really interesting when you look at this technology, where they've come. They still have quite a few limitations moving forward. They have to get certified, from the FAA and various other institutions, because most of the certifications right now are only for, existing type internal combustion engines. It's not for energy storage systems using lithium ion systems. There's a lot of safety related concerns in regards to thermal runaway, and the way that you're going to route coolant systems throughout this system, but also it's the way that these aircraft fly, because traditionally when you have some kind of other propellant, when you're flying, you're going to start losing weight, you become more efficient. With these type of aircraft, the battery system is stable, so it's really, the batteries are going to be, 4,000 or 5,000 pounds. It's 60% of the weight of the aircraft. So they have to do a lot of manipulation and aerodynamics to overcome these obstacles, and they're going to have some hybrid-based systems I envision in the future with hydrogen integration as well. But in the way that I foresee it, in the next 3 to 5 years, these type of technologies are going to take off. You're going to have air taxis picking you up from the airport and transporting you 100 to 150 miles away in lieu of using, traditional car-based transportation. And that's just one of the ways that this technology is absolutely going to transform the world. So let's dive into this. I'm going to jump into a mixed reality visualization of this so you guys can actually see this with hand tracking. And then I'll jump into some more of the advanced integrations and discussions in regards to, three-phase IGBTs, the electric motor technology, the energy storage system between 400 and 700 volts, and the design and the safety-related concerns that have to be, kind of included within that. So thank you guys so much. I appreciate it. Let's go ahead and get started. Hello and welcome back. So let's talk about the energy storage system first. Because of the weight distribution on the Eviation Alice, they had to actually place the batteries in multiple locations within the airplane's infrastructure. So they couldn't just put it in one spot. They had to actually put probably 30 to 40% underneath here in this spot, and then distribute it on each side of the wing so the weight was distributed appropriately. And it should be approximately between 6,000 and 9,000 pounds depending on the kilowatt hour. I believe it's about 840 kilowatt hours for 2 of the magniX 650 electric propulsion units. And this is very important to note, because unlike other types of aircraft, this weight is not going anywhere. So when you take off, you're going to have 60% of that weight, and when you land, 60% of that weight. So you're not losing it as propellant, which is an advantage in other types of aviation methodologies. So it's very important to understand. But also within the system here, Eviation Alice actually designed the composites of this aircraft to make it much lighter, which is very important. It made it more aerodynamic as well, so it can take off a little bit easier. But in regards to the I would say, thermal runaway kind of safety related issues on this aircraft, coolant is very important. They're probably using some type of liquid coolant or glycol to ensure that it maintains a lower stabilized temperature. Batteries do tend to get hotter, depending on the age and degradation of the batteries. I believe these are designed for around 800 to 1200 cycles, so about 3,000 flight hours. The cost to replace these batteries is between $200,000 and $300,000, which is kind of like an overhaul for an engine type system for maintenance, scheduled maintenance within the FAA. So it's equivalent, it's comparable, but it's very important to understand the differences between the technologies, as it were. Also, looking at the design of the aircraft, it's only this one. It does not go up, past 32,000 feet. In kind of this first design year, is only supposed to hold, I believe, 9 to 10 passengers. In the future, as batteries get lighter with higher energy density profiles, the ability to take off and for longer kinds of trips will be much easier. And again, it's always about safety related concerns, and this is why I believe the companies will start to integrate a hybrid type technique and methodology to include hydrogen-based technologies. We always forget that in the future, the skin of the aircraft will be solar panels, right? They'll also have the capability to generate, electricity from smaller wind turbines potentially around the aircraft. So making it much more efficient so the batteries can be recharged while it's flying and not just when it arrives, because then you have a turnaround time of between 1 and 3 hours, again, depending on the utilization and the degradation of the batteries, to recharge the aircraft and to get it back out, which makes it much more efficient, than other types of propellant-based systems, internal combustion-based systems, diesel fuel, and so on and so forth. So it's really an amazing piece of technology. They have a few different types of electric propulsion units, the magniI 350, the 650, and then they have their inverter technology, the magniI Drive, which I'll review in the virtual reality aspect of this video. So I really hope you guys appreciate kind of the insight here, what it looks like. It's truly an amazing technology, and it's something I think that's going to take off into the future. Pardon the pun. Let's go. Hello and welcome back to the virtual reality component of this training video. Firstly, I wanted to kind of come back and comprehensively discuss energy density. So when you're talking about jet fuel, it's approximately 12,000 watt hours per kilogram versus kind of something typical in a Tesla Model 3 right now, 250 to 300 watt hours per kilogram. So it's anywhere between 20 and 30 times higher for that kind of a energy utilization. It's very important to understand that jet fuel does not experience negative impacts in lower temperature environments where batteries are very sensitive to low and high temperature variances. So this is an advantage for that right now, but also you have some inefficiencies there on the jet fuel and combustion. So, technically speaking, it's probably about 15 to 20 times on orders of magnitude for the energy density variation. But more specifically, before I jump into the IGBTs and kind of the placement of the batteries here, we were talking about hydrogen before, and hydrogen is also not exceedingly efficient as well. It's about 40 to 60% if you were capturing some of the heat. It can get up to 70 to 75%. And again, you're just injecting hydrogen on the cathode, oxygen on the anode, using some kind of a catalyst like platinum, and on the cathode and nickel on the anode, and you're basically outputting water vapor. But again, if you're using solar and wind farms to capture and convert water into hydrogen, again, you can get up to 70, 75%. But there's all these different issues, both quantitatively and qualitatively, when you're using energy sources in regards to electric propulsion, moving forward in the world. So I just wanted to briefly discuss that before we kind of walk around this beautiful 3D model we have in this virtual environment. We're going to release this open source APK for anybody who wants to try it. It's really cool. We actually just created it this morning, okay? So let's talk about the battery placement here for the system. It's about, I think, for the two 650 magniI engines you can see on either side over here, I think it's about 640 kilowatt hours per engine, so it's about 840 kilowatt hours for the battery system. So they'll most likely have a battery system here in the back, and then they'll have one up here again because they have to redistribute the weight throughout the aircraft. So there's going to be a battery system here. You have coolant also running all the way through this composite airframe, and then maybe some battery components out on each side of the wings. So that's really, really vital to understand how they're actually distributing the energy throughout the system. And then they have these going out to their basically their inverter systems. And this is a three-phase motor, so they're most likely not using a typical induction motor. They're most likely using some internal permanent magnet motor via synchronous reluctance motor like a Tesla. This is going to essentially mitigate any eddy currents or harmonics and lower conversion for power issues via efficiencies, but also it's going to create less exothermic heat for the system, and that's really important. We want to keep the efficiency for these systems as high as possible, okay? And look how beautiful this model is. This aircraft's fantastic. So let's come back to the battery system. I think it's about 8,000 pounds altogether, so it's about 60% of the weight, and that's really critically important for you to understand. That weight never changes. Even with the degradation of the battery, it's always going to be around 8,000 pounds for the aircraft, so they can only hold within this typical construction design and by the manufacturer about 9 passengers, about 2,500 pounds. Okay, so if you can imagine in the future, if they can reduce the battery footprint, the size of the battery, but increase the energy density without any increasing thermal runaway type issues, then that's a really important factor to consider. Material science is going to play a big part here. There's materials like triphenyl phosphate, which they can encase in the battery, which essentially mitigates thermal runaway as the battery starts to reach some kind of exceeding exothermic temperature. And that's something to always keep critically important as well. So, and then their inverter technology in the magniX 650s, so they'll have essentially 2 of those inverters, or 2 to 4 inverters per 650 engine. So they'd have 4 of those inverter technologies. It's essentially an inverter is an insulated gate bipolar transistor, right? So that's a switch. So you have these in an H-bridge configuration. It's going to create a square or it's kind of sinusoidal wave that's going to be fed into that motor. That's going to create an electromagnetic wave in there that's going to create essentially a controlled mechanism to create energy for the engine. And that's why the batteries are so important. But in the future, they may have some kind of a fuel cell type configuration with hydrogen slash lithium ion, throughout the configuration. And I think that's the way forward. It's not going to be just one technology that's going to bring us into the electrification, throughout the entire power grid and through all the electric propulsion through autonomous navigation and aircraft. It's going to be a hybrid configuration. And as I spoke about earlier, I envision a future where the entire skin of the aircraft is all solar panels, right? And they're also taking advantage of the wind that's coming, they're going a certain speed. They're able to capture that energy and return it back to the energy storage system. So right now that is not in place. It's very bare bones. They have to get certified, which is a very difficult process. There is not an electric vehicle in aircraft that is really certified for long range or short range right now. So they have to overcome all these obstacles, prove that the aircraft is safe, and they're going to do that. I believe it's just right around the corner. Tesla has proved that they can accomplish that mission, and look what they've done. They're on the cusp of potentially having, $1 to $4 trillion market cap and beyond. And I think they're only touching the surface on that. So these types of vehicles, these types of transformational paradigms are going to absolutely change the world. They're going to impact every part of your daily life. So let's go on inside and kind of take a look at this. And we're going to zoom right up on up here. This is beautiful. So imagine coming on an electric vehicle, low carbon footprint, it's green. And you come on here, you take a seat, it's quiet. I think this particular design is not for a pressurized cabinet, so it has to stay underneath the ceiling of 32,000 feet, but that's fine. I mean, it's only supposed to be about an 1.5 to 2 hour flight, and that's what they're trying to capitalize on here. The current market, within these regional kind of aircraft transportation circles, is they want to take advantage of those opportunities, because all of the competitors, they're using these huge, massive, machines they're utilizing jet fuel, which is unbelievably inefficient for an 1.5 to 2 hour flight. If the entire flight is not packed full, if you have thousands of these kinds of aircraft across the world, now you have all these regional airports that are able to be revitalized. Look at all the economies that are going to be impacted by this technology. It's really quite, it's an amazing thing. It's something I imagine all the time because it's not just part of, some futuristic world where it is not going to happen. It's happening right now. The future's already here. It's just not, it simply is not evenly distributed. Okay. So thank you guys so much for kind of following me along, and something that we created within the last 12 hours. I wanted to say thank you to Nicolas Cadel as well. Your imaginative prowess and your creativity is unsurpassed. I'm so blessed to have worked with you on this and many other projects. And we have other things on the horizon as well that we kind of want to bring out, to the community, because I think it's really important to empower individuals with knowledge and wisdom to share this information. And we're also going to actually openly share this APK. As I alluded to previously, you'll be able to download this and experience it and kind of walk throughout this aircraft and educate others on the future of electric propulsion. Thank you so much. I hope you guys have a wonderful day.